Okay, we're on day 45, even though it says day 42 at the bottom, it's day 45. Part B, we want to finish up our lessons. We're going to go back to lesson 1. Okay, here we go. We're working on surface area some more. Surface area is the area on the outside. If you wrap something in paper, you want to know the surface area. If you paint something, you want to know the surface area. And of course, this is not the surface area of flat walls. This is the surface area of three-dimensional shapes. This page is on the surface area of spheres. So let me find our page that gives us the formula for that. Here's a sphere. And it says the surface area is equal to 4 pi r squared. Now, pi r squared is actually the area of a circle on the inside of the sphere. If you took this flat circle here, a circle on the inside like a dish in the middle, the surface area of that is pi r squared. So you would need 4 of those areas to cover the outside of a sphere. That's actually one you can almost remember. You take the area of a circle inside the sphere and you multiply it by 4. 4 of those are needed to cover a sphere. Why? I have no idea how they figured that out, but that's what the formula is. Okay, so doing this page, we have to find basically the area of a circle on the inside and multiply it by 4. So this first one, we have a radius of 6 millimeters. So how do you find the area of that circle? Radius squared pi. Pi times the radius squared. And then we're going to multiply that by 4. So if you plug in your numbers, 4 times, they say use 3.14 times 6 squared. What is 6 squared? 6 squared is 6 times 6. Anyway, if you plug that into your calculator, you should get 452.16. It says to the nearest tenth, so I could change this to 0.2 because 6 rounds up, right? There's a tenth. 452.2, and what's the label? It's millimeters, so you say squared millimeters. You could write it like this, millimeters squared, or you could write squared millimeters. Okay? Number 2, same way, 4 pi r squared, so you have 4 times 3.12 is pi times 3 squared. 3 squared would be 3 times 3. Oops, sorry, you don't see any of that. 4 times pi times the radius squared, 3 squared. 3 squared is 3 times 3 is 9. Anyway, if you do this, it actually comes out being a fourth of this, because this is double. 6 is double 3. This one's twice as big. So when you square it, it becomes 4. This one's 4 times as big. So you can divide this one by 4. Or you can multiply it out and you should get 113.04, I think it was. 04, which if you round it, that would round down to 0.0 because 4 is less. And that would be squared centimeters. Centimeters squared. 0 centimeters squared. Okay? So you can do the rest of these just plugging it into your formula. What's the formula? 4 pi r squared, or 4 times the area of the circle on the inside of the sphere. Anyway, you could do this for practice so you kind of get it down. But again, it's the kind of formula that they would give you on a test. They're not going to expect you to remember that formula for a sphere. I certainly didn't remember it, even though it seems like a relatively easy formula. Okay. Moving on to page 13 of 15, more surface area practice. Remember, we're doing surface area, not volume. So on these prisms, to find the surface area, you really basically have to find the surface area of how many sides? 2, 4, 6 sides. Think of a die, a dice. A die, which is the singular of dice, has 6 sides. How do you know? Because they're numbered 1, 2, 3, 4, 5, 6, right? So there's 6 sides. Now in a prism like this, 2 sides are going to be 3 by 4. So you go 3 times 4. That's 12. And there's 2 of them. So that would be 24. But then you have to do 3 times 5 for this side. 3 times 5 would be 15. And again, there's 2 of them. And which one didn't I do? The bottom and the top. 5 by 4. 5 times 4 is 20. And there's 2 of them. So you would have to figure out the area of the 6 sides, the 3 pairs, and add them all together. Same thing for number 2. Number 2 is a little easier because it's a cube. They're all the same. So oh no, I'm sorry, it's not a cube. Oh yes, it is. 2 by 2 by 2. So one side would be 2 by 2, 4, and of course there's 6 sides. 6 times 4, 24. That one's really pretty easy. Oh, that was number 3. Well, they were the 2 prisms. Here's another prism. Again, you would have to do this side and that side, the top and the bottom, the left and the right, by pairing them up. 4 by 12, 4 by 5, 5 by 12, and figuring out each of the 3 pairs, right? Okay, let's go down to the pyramid here. So what's the surface area of a pyramid? Well, again, remember, you're not doing volume, you're doing surface area, so you have to find out the surface area of each side, because you're going to have to, if you had a big pyramid you had to paint, you would have to paint each side. So the bottom's pretty easy. It's just 3 by 3. It's a square. So the bottom you would multiply 3 by 3 and get 9. So that's one of the sides, right? Now, it's got 4 triangles. So you have to figure out the area of a triangle. What's the area of a triangle? It's the base times the height. 5 times 3, 15 divided by 2. 15 divided by 2, because if you do the base times the height, you're going to get the area of the parallelogram that 2 of the triangles form. You want half of that. You want 1 triangle. So you divide it by 2, right? But there's 4 of them, so you're going to multiply it times 4. 2 divided by 4 divided by 2 is 2, so that would be 30. They would be 30, 39. 39 if you figure them all out. But what you have to remember is just figure them all out. The base is 1, 3 by 3, 9. And the triangles, you have to figure out the triangle by doing the height times the base, divide by 2. And then there's 4 of them. Okay? Same thing with this pyramid. You do it the same way. You got the base, 12 by 12, 144. The triangle, you take half of 8 times 12, which is 4 times 12, 48. And you want 4 of those. Got it? And this last one, the cube, of course, is very easy. 8 by 8 is 64, and there's 6 of them. 360 plus 24, 384. Ta-da! Okay, anyway, these are all pretty easy, okay? The hardest ones are the pyramids because you have triangles you have to figure out. Okay, let's go down to the word problems. Again, word problems are more likely what you're going to see on the HiSET. Okay, number 7. All the edges of a metal. Try it by yourself first, okay? Put it on pause. Try it by yourself. Those others up there, you can do them all by yourself on pause. The wonderful thing about these lessons is you can just pause them, work them out first, and then check your answers with me. Okay, you all did it? Okay, if you didn't, just pause it and do it. Okay, let's read. All the edges of a metal box are of equal length. Okay, what does that tell you right away? What shape is it? If they're all equal, it's a cube. If the surface area is 150 square inches, what is the length in inches of an edge of the box? Well, that sounds kind of hard, right? So the surface area is 150. Now, it's a cube. What do you remember about a cube? They're all the same. And how many sides are there? 6. So if there are 6 sides and they're all the same, and all together there's 150, how do you figure out the area of one side? You divide by 6 because there's 150 all together, and that's 6 sides. So you want to split that amongst the 6 sides. 150 divided by 6. Did you do that first? If you did that and put in your calculator, it comes out to 25. So you know each side of the cube is 25 area. It has an area of 25. Okay? And what is the, I lost my picture here. What is the area of a square? It's just what? The side times the side. Ay, ay, ay. Can't find my picture. Coming back. Okay. Yikes. So, if the side times the side is 25, what is one side going to be? 5. Right? We know that this is 25, so S times S is 25. S is equal to 5. And there it is, A, 5. Right? Number 8. Try that one by yourself. Pause it if you haven't. Okay, let's check it out. Here we go. Which of the following is a true statement about the figures shown below? Measurements indicated are all in the same units. Okay. So this one is 5 by 5 by 5. This one is 10 by 3 by 3. Okay. So you probably have to figure out the surface area of all of them, right? So let's figure it out. This one's easy. It's a cube. So each side is 5 by 5. 5 by 5 is 25. And how many sides are there? It's a cube, 6. 6 times 25, what is it? 150. So this one you'd have to figure out the surface area by doing each pairs of sides. So this big long side is 3 by 10 is 30, and there's 2 of them, so that's 60. And the little one over here is 3 by 3, that's 3 times 3, 9, and there's 2 of them, 18. Which one did we forget? Oh, the bottom and the top. The bottom and the top is 3 by 10. Oh, that's also 30, and there's 2 of them, 60. So if you add those 3 up, what do you get? 120, 138. Haha. So B is smaller than A. Let's see what it says. The surface area of A is equal to the surface area of B. Not true. The surface area of A is half. Nope, it's actually bigger. The surface area of A is greater than the surface area of B. Well, that sounds right. Let's read the last one. The sum of the surface areas of both figure A and figure B is greater than 300. No, because this is 150. 150 would be 300, 150 and 150, but this is 138, so it's less than 300. So C was the right one. The surface area of A is greater than the surface area of B. Did you get that one? Oh, sorry, I wasn't reading. The surface area of figure A is greater than the surface area of figure B. 150 is greater than 138. Okay, last one. Try that one by yourself. Put it on pause. Okay, did you get that one done? Okay, let's check. If the dimensions of the blocks below are doubled, by how many square centimeters does the surface area increase? Okay, let's figure it out first what the surface area is. 3 by 3, and it's a cube. 3 by 3 is what? 9, and there's 6 of them, 6 sides, so 6 times 9 equals 54. Okay, what are we going to do? We're going to double the dimensions. That means it's going to be 6 by 6 by 6. They're doubled. So one side is 6 by 6. It's now 36. And again, you have 6 of them. 6 times 36. What's 6? Oh, sorry. Each side was 6, so 6 by 6. So it was 36, and there's 6 sides. 6 times 36 is what? 216. And it says, how many square inches, centimeters does the surface area increase? So what did you do? Well, it went from 54 to 216, so we have to subtract. Did you do that? You could have done it on your calculator. That was the new one. After you doubled it, that was the old one. You subtract, you get 162, and there's the answer, C. Okay, one more page. Okay, so we have different surface area problems. Find the surface area of each object in square units. Use the formulas on page 394. Well, we don't have that book. We do have our other formulas. The only one that's not on that page that I just showed you is cylinders. So how do we do cylinders? Do you remember? Well, cylinders have a circle on the top and a circle on the bottom. So you do those, right? The circle on the top would be what? The pi times the radius squared. So it's pi times the radius squared. Radius is 7, so it'd be times 7 squared. That's the surface area of the top part. So the bottom would be the same, so we need 2 times pi times 7 squared. That's one of them, right? Plus, what else do you need? You need the area of this tube of the part going around. Now, remember, with a cylinder, if you cut here, it would open up and become a long rectangle like this. So the side is really a rectangle just bent around to make a circle, right? So what's the dimensions of that rectangle? Well, this side is 5. What's the dimension of this? Well, it's all the way around the circle, which is the circumference. The circumference is pi times the diameter. So this is if this is 7 is the radius, diameter is 14 times pi. So to get this surface area, you'd go 5 times 14 times pi, 70 pi. Okay, put those in your calculator. I didn't actually do this one. Put them in your calculator to figure it out. You can use 3.14 for pi. Okay? Again, for a cylinder, you do the area of the base and the bottom, which is just the area of those circles, and then you do the area of the rectangle that's formed when you open it up. And the rectangle is 5 by the circumference, which is pi times the diameter. Okay? These you can use the formulas. Remember, this is 4 times the area of the circle. The area of the circle is pi r squared, so it would be r squared would be 9. 3 times 3, 9 pi is the area of the circle times 4. 36 pi is the surface area of that one. This one, same thing. Use 10 as the radius, so that the area of the circle on the inside would be 10 squared, 100 pi. And then you want 4 of them, 400 pi. Here we have a cone. Cone, you have to use the cone formula back here. Sorry, we're on the cone. The cone here and the cone over there, you'd have to use the cone formula, which gets the area of the base. So you do pi r squared. I'm sorry, the area of the base is over here, pi r squared. That's the area of the base. Plus the area of the side. To get the area of the side, you use pi times the radius times the side, this slanted side here. So it's a kind of strange formula, okay, to get the area of the cone. And you would have to use it for both cones. Anyway, using your formulas, you can do all those. Just go back to your formulas. Again, on the test, they would give you the formulas. They're not going to expect you to remember those formulas. The only formulas they might expect you to remember is like on a prism or a cube, because those are just length times width. Those are easy ones. Okay? Number 7. Word problem. How are we doing on our time? We're getting up there. Okay. Number 7. If the length of the diameter of a sphere is 8, how many square units is its surface area? So you have a sphere, and the diameter is 8. It's 8 going around, right? Okay, a sphere, you want to find the surface area, you want to find the area of a circle on the inside. So you would need the radius. If the diameter is 8, the radius is 4. And pi r squared is the area of the circle on the inside. Since the radius is 4, you get 4 squared, 16 pi. That's the area of the circle. And the surface area of a sphere is 4 times the area of the circle. So you need 4 times that, which would be 64 pi. And there it is, 64 pi. You don't have to use 3.14 because they kept pi in the answer. Okay? Try number 8. Put it on pause. See if you can do number 8. Okay. Did you do it? This one's a little involved, right? A cone. Cones have kind of a tricky equation because you have for surface area you have the circle on the bottom. That's pretty straightforward, easy. But you got the area of this thing, the side part, which is a little tricky. A cone pictured below has a slant height of 8 inches. You need this slant height when you're doing a cone. 8. And a diameter of 8 inches. If the cone's slant height is doubled and the diameter is halved, which of the following statements must be true? So there's 2 ways you can do this. You can actually figure out the surface area and see how it changes. That might be the easiest if you have your formulas, right? But let's think about our formula. Our formula for a cone, it says get the area of the base and the area of the side. The area of the base is pi r squared. That's the easier one. So the area of the base here is pi. Let's just write the formula. Pi r squared. Oh, that was supposed to be on this side. Plus the area of this side. I'm sorry, I'm not even writing it where you can see it. Pi r squared. That's the area of the base. The area of the side, it says, is pi times the radius times the side. Pi rs. Okay, so there's our formula, right? And what's happening? Well, they're going to double the side and half the radius. So this is going to double times 2, and this is going to go times 1/2. So if this doubles and this becomes 1/2, guess what? This part stays the same. It does not change. Over here, what happens? The radius is halved. So if you have half r and you square it, it's going to become 1/4. This part is going to become 1/4 as big. This stays the same. This is 1/4 as big. So when you add them, the new one's got to be smaller, doesn't it? Because this becomes 1/4 of what it was. This stays the same. So the new cone will be smaller in surface area. Let's read what it says. The new cone will have the same surface area as the original cone. Not true. It's going to be smaller because this is 1/4 now. This stays the same. The new cone will have a surface area exactly half of the surface area of the original cone. Well, that might be true in this case. I don't know. We're not sure about that. The new cone's is smaller. The new cone will have a surface area exactly double that of the surface area of the new cone. How can that be double the new cone? They meant of the old cone, of the original cone. That's a mistake. They meant original here. Okay. The new cone is not going to be bigger, so that's definitely wrong. A was wrong too, right? How about D? The new cone will have a surface area less than the surface area of the original cone. Well, that's what we got, that it's less. So it could be this one. This one's definitely true. But they can't both be true. This one's definitely true. This one might be true. So this has got to be the right answer. Because we figured out that it's less. Let's try the real numbers now, okay? So this one is 8 by 8 is the diameter. We want half that, the radius, 4. Okay, so this is pi. The radius is 4. The side is 8. 32 pi And this is pi r squared. Okay, the radius is 4, 16 plus 16 pi. Okay, oh, I'm writing all this down. You're not even seeing what I'm writing down. Okay, this was the original cone. I did pi times 4 times 8. 32 pi is the side, and the base is 4 inches, so it's 4 squared, 16 pi. So we end up with actually 48 pi. Now let's do the new one. We're going to double this. This is going to become 16. The diameter here is 4. We take half the diameter, which makes it, okay, diameter is half, which makes the radius now 2. So this part, pi r s, will be pi times the radius is 2 and the side is 16. 32 pi again. It stays 32 pi. But now the radius is 2, and 2 squared is 4 pi. So it's 36 pi. It's still smaller. It's smaller, but it's not half of this. This is not double this. So only D was correct. Okay? Last one. Do the last one by yourselves. See if you get that one right. Put it on pause. Okay, did you do it? Let's check here. In the cylinder below, the diameter of the circular base is equal to the height of the cylinder. What is the surface area of the cylinder to the nearest square inch? Okay, in the cylinder below, the diameter of the circular base, that's 6, is equal to the height of the cylinder. That means this is 6. What is the surface area of the cylinder to the nearest square inch? Okay, so we want the surface area, so we need the bottom and the top. That's just a circle. Half of 6 is 3. The radius is 3. And so that is pi r squared. And since the radius is 3, that becomes 9 pi. And there's 2 of them, the one on top. So we have 18 pi plus the area of this part, the side part. And again, that if you cut it and open it up, it'll be a rectangle that is 6 by what? Well, the circumference. The circumference is, that's 6. 6 pi is the circumference. 6 times 6 pi. Again, the rectangle would be 6. The side, the height is 6. The width is 6. The length would be the circumference, which is 6 times pi. And we get 36 pi plus 18 pi. 36 pi plus 18 pi is 54 pi. 54 pi. You could put 3.14. 3 times 54 is over 150. 160 times 1.4. You plug this in, it's going to be right near 170. I can just look and see. 50 times 3 is 150, so it's got to be a little bit bigger than 150. 170. Is that what you got? Okay, that's it. That's our lessons. We're done with day 45. Okay, surface area. Again, they'll be giving you formulas for most of those if you have a surface area problem. That's different from volume. Volume is when you fill something up. Surface is when you cover it. You paint it or you cover it. Okay. Until next time, adios.